Good evening, participants. Here we are discussing. Um, let me introduce myself first. Myself, Dr. Masood Siddiqui. I'm a professor at Jaipur Institute of Management, Lucknow. And I have been here for the last 15 years. Before that, I was in the Department of Statistics, Lucknow Christian PG College, and earlier with 3 years with Statistical Services, right? And I have MSc and PhD in Mathematical Statistics and JRF in Mathematical Sciences. So today we will take up the session on linear programming, and then we move to the optimization part, right? So this is our session. I am sharing my screen. Okay. So here we will have two back-to-back topics. Not necessarily both topics would be covered in today's session only, but they are very much related. So that's why the common term is linear programming, and then we move to optimization. So basically, these topics comes under a very popular branch that is known as operations research. In the short, we will say it like OR. So it started in the World War II, and Winston Churchill, the Prime Minister of England, has a major role in developing this branch. So as you know, in the initial years during the World War II, Axis countries are gaining upper hand. So these countries, so the other bloc, that is England and US, etc., they have a high level meeting, and from that meeting in a new branch has been developed that is known as operations research, which constitute different domains of the knowledge like mathematics, psychology, physics, and etc. And so this started with World War II. That's the name operations research. So primarily operations come from the military operation. And after the end of the World War, when second industrial revolution has started, then industry has adopted this plan. And because of the emphasis on the operations, it will remain as operations research because they cover a wide range of industry problems. And with the passage of, in India, also the first operations research unit was established in 1953. And after that, this operation research has been adopted by various businesses and the various branches of the planning has been incorporated in it. Means now it will covers not only operations and production. And after that, it also covers the marketing part. It is also related to the finance and HR planning. And obviously, statistician or operation research has a major role in developing this plan. And because of these domains, now it is also known as management science. So the new or the popular name for this operation research is management science. And a very famous organization informs is very much behind the practical application of this part. So today we will introduce this concept, then we move to the other part. So first I will start with the formal definition. This definition was given in around 1957-58. Obviously quite an old definition, but it still covers the entire part. So operation, I am taking this definition. So operation research is the application of scientific methods and techniques and tools, right, to the problem involving operations of a system, right? So the important thing is it is related to a system or operations of a system so as to provide the decision maker with the optimum solution to the problem. So the next important part is the optimum solution to the problem. Here the first word is scientific methods, tools, and techniques. So obviously the scientific methods, tools, and techniques means these tools are objective in nature and there is a systematic approach toward this problem. So here we will cover both objectivity as well as systematic approach. So they constitute the thing that is known as scientific method. Then it moves to the operations of a system. This system may be of any business situation or any situation where decision making is involved. So obviously the system involves all the things like operations and production, marketing, finance, HR, and the various domains of the practical knowledge. And the purpose or the objective of this operations research technique is actually to find out the optimum solution of the problem. Optimum solution means this is the best in that situation. It is the best in that situation, right? So further, the other operation researchers has given another definitions like OR is the scientific approach to the problem solving for executive management. So the word that is used is management. And here again, Wagner also has re-emphasized the scientific approach. And one very important definition was given by Satie. Probably you know that Satie has developed a very important qualitative operation research technique, that is analytic hierarchy process. According to Satie, OR is the art of giving bad answers to the problem which otherwise have worse answer. So operation researcher never claim that they give the best answer, but obviously if these tools and techniques are not used, then the answers would be worse. So the bad answers means it is better than other answers in that situation. Right? So that's why the word that is known as optimum means this is better than all other possibilities in that situation. Right? So these are the three definitions. There are n number of definitions are also there, but these are the three definitions that broadly covers all the concepts. So I have included these three definitions. So in operations research, we start with a model. Right? So actually the model is the replica of the real system. It is a replica of the real system or the replica of the real situations. Right? What do we mean by replica? Replica means where only the important or core things are considered. So only important and core features are considered. So model can be termed as a simplified representation of the system, replica of the system, considering the core features. So the first thing that an operation researcher faces is to develop a model, because this model will be solved as we move forward. Right? So the important thing is related to the modeling. So now we will discuss what do we mean by OR modeling. So as we have discussed, this is a simplified representation. So we can divide any type of model in three categories as per the structure wise. The most elementary being iconic model. Most elementary being the iconic model. Iconic model means this is the pictorial models, where some pictures are used to depict something. Right? As we have always seen that we use the diagram of amoeba, paramecium. They are used to represent the system. Right? So this is the iconic model or any picture-wise representation of the thing. It can be of any building. It can be of any operation system. But the problem with the iconic models are they are stationary in nature. So they don't incorporate any changes or the variability. So since they are iconic in nature, so they are not used in operations research because they don't represent the dynamic part to which our subject of interest operations research cover. So we don't discuss the iconic model. Analog model are somewhat of higher degree than iconic model. The example of they are not exactly the pictorial representation, but they consider the important, they take up the important thing that is inherent in the iconic model. The examples being the flow chart of any diagram, or the maps, etc. So they are the analog models, but they also represent the static nature. They don't represent, though they represent the different steps of that system or steps of that process. But even then, they don't represent the dynamism that is required in any operations research concept. So we don't include analog model in our discussion also. So now we will move to the model that we are taking up for our further discussion. They are known as mathematical model. So as you have read, this is the mathematical model, means where the concepts of mathematics, algebra, functions, etc. would be involved in order to explain the things. So this is the model that would be used in any OR or management science project. So we will discuss the concept related to mathematical modeling of our situation. Right. Now we will discuss how this OR project or OR study is being developed. So these are the broad stages. These are the high level stages that we cover. Right. As we know, okay, with the advent of business analytics or data science, we basically cover the three steps of any analytics project or data science project. It starts with descriptive analytics. Then we move to diagnostic analytics, where we diagnose the things. The first one is the describing the situation, diagnostic analytics. Then we move to predictive analytics. Then we predict the future, predict the problems related to. And the last one is related to prescriptive analytics. Right? And here in the prescriptive analytics, operations research is being employed. OR models and the solutions related to OR model has been employed. So that's the reason that OR project methodology has become so important, because this is the last step of any data science or analytics project. And from here, the solutions are deployed. So it has a very important connotation when we consider any real life situation where decision making is involved. So as we start explaining the OR study approach, or what approach should be followed. The first step is related to identification of the problem. Why identification is important? Because as we receive the problem, so the problem that we receive is normally quite hazy in nature. Means there are lots of information that are irrelevant. Every information is not so relevant. Things are quite fuzzy in nature. So we have to identify the problem. Identification of the problem means, just like if we consider the funnel, right? So lots of information has been entered, right? But only we consider only in those information which are relevant for our problem. So we consider identification of the problem. So we will take up a case. So from that, we will identify the problem. We will discuss how the problems can be identified. So the first step is related to identification of the problem. Means making it useful for the study. And after identification, we move to our main important part, that is known as construction of the model. So obviously here we would develop OR model, right? And here we would basically consider the mathematical modeling part, right? So if we identify the problem well, if the problem has been identified in a good manner, then we move to a construction of the model. obviously the model depends upon the identification. So that's why identification is so important, because model is based upon that identification only. So after we develop the mathematical model, obviously in the mathematical model, we convert the real life into a mathematical set of functions and relations. Right? So here we develop a mathematical model, which is a set of mathematical functions and relation. So here in this step we perform that. Now we want the answer for the real life, but this we cannot directly solve the real life because of the large number of complexity that are involved. So we try to solve this mathematical model. So it comes under solving the model. With advent of the software, now we have a number of softwares that are available to solve this model. But obviously, in order to consider the proper application of the software, the basic and the fundamental concepts behind the solvings are important. So we will discuss what are the basic or fundamental concepts behind solving of these two models. Right? So after the model has been solved, so here the solution of the model is being solved. Now here the thing is, we want to impose this model on the real life. So before implying or imposing the model to the real life situation, we examine whether where our model is valid or not. So the next step comes out to be examining validity of the model. If model is valid, then only we move to the deployment part. And after that, since we are considering the business situations or the real life situations of anything that is of interest, whether we are going for the engineering branch and so on. So the real life situation or business situations are very much dynamic in nature. The environmental factors affecting those those problem situations changes in a quite regular and a quite expedite manner. So here the model should be controlled, and these changes should be incorporated in our model. Otherwise, the model won't be very useful for the change situation. And after incorporating the changes or the suggestions related to those changes, we move to the deployment part, means the solution has been deployed for the real life action. So these are the broad 6 steps that are used in any typical operations research study or operation research project. Now we can divide these 6 stages into 3 phases. The first phase, that is the most important phase, is related to identification phase. We identify the problem and we find out, we incorporate the important things, important features that are that would be relevant for our problem solving. So first we go for the identification, then we go to the research phase. Research phase consists of all these stages where we construct the model, then we solve the model, then check the validity and control we control the model uh, with respect to the changes that are inherent in the problem situation. And then finally, that is related to action phase. Action phase means we employ the model or deploy the model. So this is related to deployment of the model. Okay. These are the phases that we would take up in any OR study. When we discuss the cases, so all these steps would be clear in a real life situation. So now we are concentrating on the main part of the OR modeling. Why we model and what are the essential things of a mathematical OR model. Okay. So why modeling is so important? Why modeling is so required? So in the real life, we have limited resources, right? So normally it is also related to the planning part. As we know, that planning is required only in those situations where we have limited resources. So we have limited resources and we want to allocate limited resources into competing activities. There are a number of activities that may be considered. So there are a number of competing activities that may be considered. So we want to allocate limited resources. So these competing activities, and this allocation should be in an optimal manner. Optimal manner means it should be best in that situation. Means it should be better than all other options that might be considered. So here these things, the first thing is there must be an allocation of the limited resources among competing activities in an optimal manner. So accordingly, we have the three things. Number one, there are competing activities. Number two, this allocation should be in the optimum manner, but these resources are limited in nature. So from these three concepts, we develop the three essentials or the three core features of any OR mathematical model, right? We would discuss how these competing activities has been taken care of. Then we move to the optimal manner, allocation in an optimal manner. And in the same manner, that these allocation are of the limited resources, right? So these are the three phases that we consider. So first, we will discuss the definitions related to these concepts. Then we will take up a case and we will discuss how these things are incorporated. So this is the OR model essentials or the core features of any OR mathematical model. As we have discussed that we will have only mathematical model discussion related to the mathematical model only, because this is the most useful model. So the first thing is what are the decision alternatives that constitute of the competing activities on which we have to take decision. So they are technically known as decision variables. As we have mentioned that they are the variables, right? So these variables has comes from the mathematical part. Since we are taking up the mathematical model, so the terminology should also be relevant to the mathematical or the statistical part. So first are the decision alternatives, and these decision alternatives are better known as decision variables. And obviously these decision alternatives constitute competing activities. So this is an alternative that we seek to determine. We want to know about these decision alternatives or the level of these decision alternatives or the level of competing activities. So this is our goal that we seek to determine. Seek to determine what are our decision variables that constitute the decision alternatives or the choices or options we have. In a common man's language, you can use the word choices or options in front of us. And after that, we move to allocation in an optimum manner. So this is our main purpose of uh, doing the modeling, right? And this purpose is also known as goal of the real life or goal of the business situation. So this is known as objective function. So these objective functions, obviously, these competing activities are to be allocated in optimum manner. So these objective functions are also functions of these competing activities. Right? So they are the functions of the decision variable, means they constitute the decision variables part. So they are the functions of the decision variables, right? And what is the purpose of the objective function? So one part is function. Function means they are the functions of the decision variables. The other part is objective, because they should be allocated, they should be determined in an optimum manner. So being optimum depends upon the situation under consideration. So they represent the measure of effectiveness of the system, means how the effectiveness of the system can be measured. So accordingly, we develop an objective function. So objective function are the functions of the decision variable or the functions of the competing activities. And since they are allocated in an optimum manner, so they represent the measure of effectiveness of the system that we try to optimize. The important word is try to optimize, means we try to make it the best as per the situation. So obviously optimize means if the thing under consideration is positive in nature, so we try to maximize the thing. And if our things are negative in nature, then we try to minimize. If the things are negative in nature, then we try to minimize. Right? So the word is try, means we will try. It is not necessary that we can optimize or not, but we will definitely try. And the last part comes out to be the allocation of the limited resources. So this allocation of the limited resources constitute the third essential or the third component of any OR mathematical model that are known as constraints or restrictions. Again, since competing activities are to be allocated, so they are the functions of the decision variables. They are the functions of competing activities. Or the functions of the option. They represent the physical limitations or the conditions or the aberrations imposed on the system, right? Because they are not in abundance of the nature. They are always limited in nature. So they are limited in nature. So these limitations impose some condition, boundary conditions upon the systems. And obviously, since they are limited in nature, so they has a negative impact upon the fulfillment of the objective. So they try to reduce the complete fulfillment of our objective. And they are paramount in nature. They are paramount in nature. What do we mean by paramount in nature? Means they must be followed. Means we can never ignore the constraints. Right? So anything that should be considered should constitute the part that they must be covered in that. So these are the three things that we will take up in our further discussion.